looking at number rules and linear graphs. So we can imagine I made this pattern here using matchsticks, and each time there's a new step in the pattern, another triangle is added. So in the first triangle, there are 3 matchsticks. Now I'm going to call the first triangle term 1. And then when there's a triangle added, I'm going to call that term 2, term 3, term 4, and this pattern actually could keep going indefinitely. So we're now going to work out the rule for this pattern, and one way to do that is by first making a table of data. So I have on my top row the number of triangles. So the number of triangles in term 1 is 1, term 2 is 2, and you can see it actually matches the term number, and we'll go up to 5. And then I will fill in my bottom, which is the number of matches, or we can call it M. And in term 1 there are 3 matches, in term 2 there are 5, in term 3 there are 7, in term 4 there are 9, and in term 5 there are 11. Now the rule for this pattern is M, or the number of matchsticks, is equal to the term multiplied by 2, so 2t, plus 1. And the reason I want to come up with an algebraic rule is it's not always reasonable to list the pattern out to a large number of terms. So by coming up with a rule, I could actually calculate the 90th term without needing to lay out 90 triangles. Now how I got the rule as m equals 2t plus 1, there's 2 different ways. The first way is I can look at my data table and I can see that in term 1 there are 3, and in term 2 there are 5 matchsticks, term 3 there are 7 matchsticks. And I stop and I go, how does that happen? And I can see that if I actually multiply 1 by 2, I get 2, and if I add 1, I get 3. If I have a look at the next step, if I have 2 and I multiply it by 2, I get 4, plus 1 is 5. So we see that the rule works. The other way to actually have a look at it is look at the pattern at the top, and I can see that every time I add a triangle, I'm actually adding 2 sticks. So that's where the times 2 comes in, the multiplied by 2. So every time there is a new triangle, there are 2 matches added, and this plus 1 actually comes from the original triangle where there is this 1 extra stick, and that's in every one of the terms. Now, as I mentioned before, I could actually now use the rule to calculate the number of matches needed to make the 100th term. So if it's going to be term 100, this would be multiplied by 100, so there would be 2 times 100 is 200 plus 1. So in the 100th term, I would need 201 matchsticks. I can actually now turn my rule into a graph, and when I look at my data table, it's actually set out as x and y coordinates already. And you can see my axes are labelled. The triangles are on the x and the matches are on the y. And I can list out my coordinates. So the coordinates would be 1, 3, 2, 5, 3, 7, and 4, 9. And I can plot my points. So 1, 3, 2, 5, 3, 7, and 4, 9. And you can see that this line is actually a straight line and it's a linear graph. And I put the arrows on the end to show that this line can keep going forever.